So I want to show you now using the formula how you can answer this question. This is our example on half-life. So remember we said the initial mass of the radioactive sample was 256. The final is 8 grams and it has a half-life of 3 hours. The question says we find the total time of decay. In other words, what's the time it will take to move from 256 and reduce to 8? That's what they mean. The total time, or they are going to be saying the total period. So they are going to sometimes use the total period of decay. So you can simply use the exponential equation. So to find the number of for you to find the number of half lives. So for you to find the number of half lives n, we use the exponential equation 2 raised to the power n is equal to NO divided by n. Now where n naught there, this one here is representing the initial, what you start with, the number of unstable nuclei you have started with. Then this n is representing simply the final number of unstable nuclei that you have. So it will be 2 raised to the power n will be equal to, so what's the initial? The initial mass that we have there is 256 over the final that we are remaining with is simply 8. You can get a calculator. So if you divide 256 divided by 8, that is going to give you a 32. Now of course, since the base this side is 2, you need to write this 32 with a base of 2. If you struggle with that, you simply need just to get this number and just start dividing. 2 into 6 into 32 is 16. 2 into 16 it's 8. 2 into 8 is a 4. 2 into 4 is a 2, and 2 into 2 is 1. So how many 2's have gone into 32? 1, 2, 3, 4, 5. So meaning that this 32 can be written as 2 raised to the power 5. But because the bases are the same, you compare the powers. So meaning that n is equal to 5 half lives. Remember, even in our previous video, this is what we got. We got 5 half lives. So once you get the 5 half lives, now you can know the total period of decay. Remember the formula, the total period of decay is equal to, in this case, the number of half-life multiplied by the half-life of the sample. So the total period, the number of half-lives, we have found it is actually 5. And what is the half-life? The half-life is simply 3 hours. So therefore the total period will give us 15 hours. So meaning it will take 15 hours for the sample to move from 256 to reduce to 8 grams. So you can see that they are going to be asking you such questions in the exam. Now sometimes they can even tell you what fraction. So if you want to get the fraction of what is going to remain, what we do, using the same exponential equation, 2 raised to the power n is equal to the initial divided by the final. You can simply since you want to know just the fraction, you can simply make, in this case, n the subject of the formula. So this will go there and this will come there. So your n will be equal to, it is going to be NO divided by 2 raised to the power n. But this can actually be written, if you go back to, I can write it as 1 over 2 raised to the power n, in this case, multiplied by NO. Remember, NO is the initial. But of course, we can rewrite this and simply say, n is equal to 1 over 2. This I can write it as 1 over 2 raised to the power n multiplied by NO. I've not changed anything here. Remember, if you write 1 over 2 raised to the power n, that is the same as saying 1 raised to the power n and 2 raised to the power n. 1 raised to the power n is 1, and that will give you that. So we have not changed anything. So meaning, if you want to get the fraction of what is going to remain in a sample, we apply the formula 1 over 2, raised just to the power n. So if you just want to know the fraction, but if you want to know the actual fraction that will remain if they have given you the initial, then you can simply apply this formula. But if you just want to know the fraction, then you just need to know the number of half-lives. For example, in this question that we did, previously. If I just wanted to know the fraction, it would have been 1 over 2. Remember, the value of n, the number of half-lives, was 5, so it is going to be raised to the power 5. Of course, that will give me 1 to the power 5 and 2 to the power 5, which will give me 1 over 2 to the power 5 is 32. So the fraction that would remain after, you know, those number of decay is going to be 1 over 32. But of course, if you wanted to know the actual one, like I said, you can get that same 1 over 32. Then you simply multiply by the initial what you started with, which is a 256, and it will give you 8 grams. So that's the 8 grams that we have there. I hope it makes sense. Watch out for some more videos so that I can actually get to teach you even on, you know, activity.